Alrighty, this is Mr. Vaughn with the 7th grade material for the beginning of Chapter 4. This will cover lessons 1 and 2. Basically, coming down to what are we talking about? We're talking about decimals and fractions with negatives. So you have your Cornell note form there. This isn't the exact same format as your Cornell note form, but it's very, very close. So all the information's there. Topic objective is decimals. I don't know. I should have written decimals and fractions with negatives. Decimals are comma fraction. The essential question is, what happens when you add, subtract, multiply, and divide decimals and fractions that are negative? That's the essential question for the whole chapter. The vocabulary and questions, let's jump right into it. So for lessons 1 and 2, there's the reference pages. Lesson 1, get into that right now. Lesson 4.1, there's some vocabulary, which I'll go over in just a second, and then we'll talk about that just in a second. So, if you go to page 263, this is a review from 6th grade, so I'm not going to have you write it down unless you really feel like you need to. Feel free to if you feel like this is something you need to remember. So, just a quick review. Some decimals when you switch, or fractions when you switch them into decimals, they are repeating decimals, right? So that means they go on and on forever. If they do repeat the same number or series of numbers, you use bar notation to represent that. So if you get something that's a 0.3333, you don't want to write that forever, so you write 0.3 with the bar over it, whatever is repeating. Here, the 12 is repeating, so they have that over that. And you're going to have 4 or 5 numbers. Repeating decimal, use bar notation. Terminating decimal means that it terminates, it ends, right? So, 3, let's do an easy one. 1 divided 1/4 as a fraction, or as a decimal, is 4 into 1. You add that onto there, and you keep on going. Let's see, that's 2, and this is 20, and you bring that down, and it terminates, it stops right there. So it's 0.25. That is a terminating decimal. If you feel like you need to review or write those down, you surely can. Let me erase this before I get back to the other thing. Basically, all lesson 1 is saying is that, what I just showed you, as well as knowing that the sign goes with the fraction or decimal. So if you're converting something from a fraction to a decimal, you can take it with it. So on this example that I did over here, if that happened to be a negative 1/4, I would do the same exact conversion, and then it would be a negative 0.25. Ooh, that's it. The negative sign goes with it. Everything there is to know about lesson 1. Lesson 2 gets a little bit deeper, and it talks about something called rational numbers. And here's the reference pages for those. Rational numbers has a big, long definition that you should probably write down. There it is, all there. Rational numbers. They are numbers that can be expressed as a ratio of 2 integers written as a fraction without 0 as denominator. If I was you, I'd freeze the video so you can get that written down, and we'll do several examples. On page, this is going to take a while, 271. 271. It has a nice little diagram about one more. About rational numbers. Here's that definition again. Can be expressed as a ratio as integers, which is not 0. Okay. So check out this little graphic organizer there. So elementary school, you had whole numbers, right? Regular old whole numbers. Then this year and maybe a little bit last year, we've expanded that to integers. That is whole numbers and their opposites, which means it's a negative, right? So still no fractions, no decimals. They're integers, just the whole numbers and their opposites. We're expanding that into rational numbers, which are numbers that can be written as a fraction. Okay, let that digest a little bit. Now, rational numbers include integers and whole numbers. That's where they're inside the circle. So if I take this whole number 2, I can write that as a fraction. Doesn't 10 over 5 equal 2? So this is equivalent. So 2 is a rational number as well as an integer. Okay, but like negative 1.4 is not an integer, and it's definitely not a whole number, right? So that's why the circle's written like this. The reason we're doing this today is because you have something called irrational numbers right there. Those are numbers that don't fall into any of these categories. Pi is the most famous example of that. You can read more about that down at the bottom of the page. They are numbers that don't repeat and are non-terminating. So that means you just go on forever randomly, throwing out numbers, right? So that's what a rational number is. So let's go back to the notes, and we will give a few examples here. I can just pull that down, rational numbers. I don't know why we got this random line going through there. I've tried to get rid of it and just can't. So yeah, maybe we don't need to do that. Yeah, I think I just gave you enough examples. So, if it can be written as a fraction and doesn't and is terminating or repeats, then it's rational. Okay. So on to the next part of it is comparing and ordering. And this is where most of the quote-unquote work will come. Fractions and decimals. And again, you guys are taking your own notes, so you write it down however you see fit. Comparing and ordering fraction and decimals. So it's pretty much the same as when they're positive, but you do have to consider more because just like when you're ordering integers, you have to think about which one's further to the left. Which one's further to the left. So let's I think the best way to do this is just jump into some examples. So let's say you were asked negative 4/5, is that greater than or less than negative 1/5? So you got to ask yourself which one is further to the left on the number line. So if you're looking at a number line, and you've got 0 here and a negative 1 here, negative 1/5 is like right here, right? And then 2/5, 3/5, and there's 4/5 right there. So negative 4/5 is further left than negative 1/5, so it is less than. Okay, just like we've talked about with the integers when they're whole numbers and their opposites, you got to think about. Sometimes it's confusing. 4/5 is got a bigger absolute value than 1/5, the negative 1/5, but it is smaller than it. Same kind of thing when you are. Oops. Guess I got to put my pen down for that to work. Same dealio as with positive numbers when you're working with fractions that have don't have a common denominator, negative 1/2. You can't compare 2/3 and 1/2, so you've got to get them into numbers that are a common denominator. So 6 is their common denominator, times 2. Don't forget to bring the negative sign along. Here's going to be 6 and negative. We've got to remember the negative fraction there. So now we can see which one is negative 4/6 to the left of 3/6 or to the right of 3/6 on the number line, and that would be less than. I'll make sure I get it right. Yeah, half, and then that's more than a half. So picture that number line and say which one's further away that way. If you've got decimals, come on, bar, then it works pretty gosh darn much the same way as with positive numbers. You just have to, again, think about whether it's to the left or the right on the number line. So comparing and ordering decimals, you might remember from the 6th grade material, the best way to do it is to just go line by digit, or place by place. So I'll switch colors so we can see that more easily. 3 and 3, it's a tie. Well, they're both negative. That's the first thing to see, because if one's negative and one's positive, it's easy to see which one's greater than or less than. But they're both negative 3, so that's a tie. they both have 4/10, so that's a tie. And then this is a 3/100 and a 1/100. So the negative 3/100 is further left on the number line than negative 1/100. So that's the tiebreaker, and it would be less than. I guess all my examples are less than. Okay. Even though this has more digits on it, goes out further, remember it's a decimal, so it doesn't matter. You got to go place by place. I think that should get you through lessons 1 and 2. Write yourself a summary summarizing your understanding of this. Any questions you have off over here on the side, and I will talk to you soon.